And here, I'll turn off my video. Maybe that'll fix the audio issue. Okay, so the output of this code, it starts as 4, and then it times equals 3. So 4 times 3 is 12. All right. Brian, can you read this one?
In-place operators. These operators can be used on types other than numbers as well, such as strings. In-place the operators can be used for any numerical operation.
All right. So what this is going to do is it's just going to combine our starting with spam and combine it with eggs, and we get spam eggs. Oh, oops. Well, this one just makes 3 A's. Mike, can you read this one?
Walrus operator allows you to assign values to variables within an expression, including variables that do not exist yet. Let's suppose we want to take an integer from the user, assign it to a variable number, and output it. The walrus operator accomplishes these operations at once. The walrus operator makes code more reliable and can be useful in many situations.
Okay, so let's go ahead and try this one out. So enter a number, then it outputs 4. This is just a regular old input that you turn to an int that we covered last week. So now with the walrus operator, run it for, and you still get the same thing, but it's kind of like saying it's going to equal this once we get that. All right. Oh, well, I did it again. Oh, well. So colon and the equals. All right, go ahead, answer the first question on the quiz. All right, so the first one, we take spam is 7, and then we do spam, which is a string because it's in quotes, plus 0, which is a string because it's in quotes. So now we've got 70 as a string. We convert it to an integer, which is a number, and then add 3, and then print it as a float. So it adds the decimal point, and we get 73.0. All right, go ahead, answer the next one. Okay, what's the output of this code if the user enters 42? Well, we take the input as a string, but then it converts it to an integer. So now that it's an integer, we can add numbers to it. So we add 42 plus 8, and we get 50. All right, go ahead, answer the next one. Okay, so this one, X starts as 5, and then y is 5 plus 3, so it's 8. And then we convert y, which is 8, to a string and add 2. So we get 82, and then print that and we get 82. All right, go ahead and do the next one. All right, fill in the blanks to declare a variable, add 5 to it, and print its value. So we've got x plus equals 5, and then we're going to print the value of it. Go ahead and answer the next one. What's the output of this code? So x is 3 and num is 17. And we do num and then the floor value or remainder. And so 3 goes into 17 until it gets 15. So then there's 2 left over. So our answer is 2, the floor value. Well, I didn't give you a chance to do this one, but fill in the blanks to take a name as input and output a welcome message. Just get the input, print it, and then welcome plus the variable name. Okay. And go ahead and work on this one. Mark, can you read this? Please.
For which one? The one I have is a simple calculator.
Yeah,
This
yeah,
one?
the
Okay, yeah.
simple calculator.
Write a program to take two integers as input and output their sums. Sample input 2 and 8, sample output 10. Remember, input bracket results in a string.
All right. Go ahead and raise your hand once you're done. And just a reminder to raise your hand once you're done. All right, looks like a lot of you are done. So, Brian A, can you do screen share and let's see your answer? I don't think that's the one. Hit the X in the upper left corner. And then go to strings and variables. And then there you go. All right, so we get our inputs and then turn them into integers and combine them and print them to the screen. Any questions on that? No? Okay. All right, so moving on. All right. Mark H, can you read this one?
Boolean. Another type of Python is the Boolean type. There are two Boolean values, true and false. They can be created by comparing values, for instance, by using the equal operator, equal, equal. Be careful not to confuse assignments, one equal signs, with comparison, two equal signs.
All right, so your comparison operators, I think we've covered that a little bit before, but your comparison you will use a lot, especially with if statements. But Boolean, again, just like in JavaScript, is just true or false. So like a lot of times you'll get if statements. So like instead of this, it will be if hello equals hello, print hello. But yeah, so Boolean's just true or false. All right, go ahead, answer the next question.
Brandon, it seems like a lot of this in general is true, false. It just the whole idea behind it. It seems like it's a lot of just putting things in line to, and if else, true, false. It seems like they kind of all work together.
Yeah, and that's totally true. Is like if statements and whether they're true or false is like a huge part of your programming, because if one set of circumstances is true, execute this block of code. If not, don't. Or if
Mhm.
not, then execute this code or move on. And like that's like the majority of what you're doing. Like the stuff we covered last week where we went over the database stuff, manipulating databases and sending stuff through forms and stuff, and then if statements, that's like 95% of what you do. So yeah, so you're totally right there. All right, so what are the two Boolean values in Python? True and false. Peter, can you read this one? Peter, can you hear me? Okay, well, we'll come back to you. Will, can you read this one?
Sure. That one is which one?
Comparison.
Comparison. Another comparison operator is not equal operator. It evaluates to true if the item begins comparisons aren't equal and false if they are. Comparisons are relations operators. Done.
Relational operators. Yeah. This not equals is another big one that you'll use. So any questions on that? Pretty straightforward. Not equal, but okay. What's the output of this code? 7 not equal 8. Well, that is true. And Kevin, can you read this one?
Comparison. Python also has operators that determine whether one number, float or integer, is greater than or smaller than another. These operators are the greater than, smaller than, respectively. Different numeric types can also be compared, for example, integer and float.
All right. I'm sure you all remember greater than, less than from school, Pac-Man and all that jazz. But anyway, what was that? So what's that for this code? Print is 7 is greater than 7. No, that's false because they're equal. Peter, can you read this one?
Yeah, can you hear me?
Mm-hmm. I can't hear you anymore.
Greater than or equal to or smaller than or equal to, okay.
Oh, are you there? You're really quiet.
Yeah, can you hear me?
Yeah.
Yeah, the greater than or equal to and smaller than or equal to operators are they are the same as should greater than or smaller than operators, except they return true when comparing equal numbers. Greater than and smaller than operators can also be used to compare strengths. Like support that the alphabetical order was based in alphabetical order of the earth. For example, the first characters from the A and A are compared as they're equal. The second two characters are compared because they also equal the third two characters and they are compared. And because N have greater alphabetical order value than B, and is greater than
All right. So any questions on this one? So basically letters are assigned numbers, right? So D is going to be 1, 2, 3, 4, right? B, C, D. And then N is going to be, you know, higher than D. So it's going to be greater than. I haven't really found much use for comparing words. But I guess you could do it if you're trying to put things in alphabetical order. That would be useful. But yeah. So go ahead, answer the next question. Then another way to put things in alphabetical order is if you put it in a list and do dot sort. So just another 100 ways to skin a cat. Okay, what's the output of this code is 8.7 less than or equal to 8.70. Yes. Okay, so we've talked about this a lot and y'all know it from JavaScript, but the if statement. So let's see. Samantha, can you read this one?
I'm still catching up from the last class.
Oh, okay, no worries.
Okay. I'm on my phone today too, so sorry.
Oh, okay. Will T, can you read this one?
Sure. Go back to that one. And go back to it. Okay. If you can use the statement to run a code if a certain condition holds, if an expression evaluates to true, some statements are carried out, otherwise they aren't carried out. An if statement looks like this: if expression statement. Python uses intention, white space at the beginning of a line to delimit blocks of code depending on the program's logic. Indentations and can be mandatory as you see. The statement in the if should be indented.
Good. So go ahead and answer the next question. All right, what part of an if statement should be indented? The statements within it. So I've said this before, but I'll say it again. So just like with JavaScript, how you execute the block of code that's inside The curly brackets, well, with Python, if you just indent it, then you execute that code that's in that indentation, and once the indentation stops, it knows that's the end of that block of code, or unless you then indent it again, if you have like another colon at the end or whatnot, then it goes on. But yeah, so any questions on that? Okay. So Peter, can you read this one?
And here is an example. Which, the expression determines whether 10 is greater than 5. Since it is the indent statement rounds and 10 greater than 5 is operated. Then the unindented statement, which is not part of each statement, is run, and program ended is displayed. Notice the colon at the end of the expression in the if statement.
All right, so just like I was just talking about, so if 10 is greater than 5, so it executes this block of code. If that wasn't true, if we were saying is 10 less than 5, then it just skips that block of code because it's not true and just executes the final statement. Any questions? Okay. All right. Kevin, can you read this one?
If statements, write a program that checks if the water is boiling. Take the integer temperature in Celsius as input and output boiling if the temperature is above or equal to 100. Do not output anything if the water is not boiling.
All right, go ahead and work on that, and then just raise your hand once you're done.
Fuck wrong with this shit? Yeah, so,
right, so most of you are done. So Mark H, can you do screen share and show your answer?
Hold on.
Okay, so you see we get temp is input, but the input is going to be a string. So first you convert it to an int and then compare the temperature to see if it's greater than or equal to 100, and if so, print boiling. As you see, the print boiling is indented there, so it's only executed if the if statement is true. All right, good job. So moving along. And this one, what's the output of this code? Spam equals 7 if 7 is greater than 5, which is true, print 5. If 7 because spam is a variable for 7, is greater than 8, which it's not, print 8. And so the only thing that's going to print is 5. Okay. Roger, can you read this one?
I can, but I ran that code and I'm trying to fix it. It's not letting
Okay,
me
you want
move
to do
on.
screen share?
Yeah.
Well, also, if anybody else ever has that problem, just remember, just unmute and let me know.
My laptop is not allowing it. I have to log out and do it.
Oh,
Oh, see if I can just. Yeah, I'll be right back.
okay, well, we'll move on and then just let me, I'll see you when you're back. All right, so. Okay. And Will, or actually Sandra, I haven't called on you. Can you read this one?
If statements to perform more complex checks. If statements can be nested, one side the other. This means that the inner if statement is the statement part of the outer one. This is one way to see whether multiple conditions are satisfied. For example, indentation is used to define the level of nesting.
All right. So, like I was talking about before, the statement ends unless like you've got another colon and it starts a new block of code here. So if we run this, is 5 bigger than is 12 bigger than 5? Yes, that's true. So that prints. And then if 12 is less than or equal to 47, print that. And the block of code doesn't exactly end. It just executes this new block of code. So we can actually, after this block of code is done executing, you can keep doing stuff in this block of code. So we could say end of first if, and then this same thing, obviously for here, once this is done, this would just be the end. So it's going to, execute this, and then since this block of code's done, it's gonna print this block of code, which is still part of this if statement. And then at the end, once this if statement's done, then it prints here. And it's the same thing for like while loops and for loops or any kind of loop. Yeah. So any questions on that? Okay. Go ahead. What was that?
The number 12, is it to gauge? Is it our starting point?
I'm having trouble hearing you. Can you try and like talk closer to the mic or something?
Yeah, can you hear me?
Yeah, now I can.
Yeah, the num is for the 12. Is it like the starting point?
Well, the num's a variable. So remember with JavaScript, we had to put var in the front when we were defining variables. But with Python, you don't need to do any of that. All you have to do is start typing something, and then it takes that, it knows that it's a variable as long as it's not in quotes or anything. So it knows it's not a string. It just knows that it's a variable. So num is just a variable for 12. Does that answer your question?
So that is any random number.
Say that again. I couldn't hear you.
Random number. Doesn't have to be 12. So the num is just a variable. So basically what I'm saying is it doesn't have to be specifically a 12.
Oh yeah, it could be anything. Like we could change it to 40, and it's still gonna get the same things, or we could make it less. We can make it just 4, and then it's not gonna do anything because 4 is less than 5. Does that answer your question?
Yeah.
Okay, awesome. All right. So next one, what is the output of this code? If num, which is for 7, is greater than 3, okay, 7 is greater than 3, so execute this code, prints 3, but then another if statement in this block of code. If 7 is less than 5, well, it's not, so it's just done. It's not, even though this is true, well, this block of code never got executed, so it just skips down to here and there's nothing. So that's all it ever printed was 3. All right. Jacob, can you read this one?
Else statements. The if statement allows you to check conditions and run some statements if the condition is true. The else statement can be used to run some statements when the condition of the if statement is false. As with if statements, the code inside the block should be indented. And then it's just example. Notice the colon after the else keyword.
Okay, so this is just like JavaScript. We've got if, and then we've got else. So if this isn't true, we're going to do this. And then later, I'm sure it'll get to elif, which is like in JavaScript, it's if else. So you can keep adding possibilities before you get to your else statement. All right, so go ahead and start on this. Let's have Roger, can you read this? And then actually, then I'll did you ever get by the last one or no?
Yeah, I was apparently missing the colon.
Oh, okay. Can you read this one?
Yeah, write a program to control entrance to a club. Only people who are 18 or older are allowed to enter the club. The given program takes the age and the name of the person who tries to enter. Complete the program to output welcome, followed by the name of the person if they are allowed to enter the club. And sorry if they are younger than the allowed age. Sample inputs 24, James. Sample output will be welcome, James.
All right. So go ahead and start on that, and then
Hey, Brendan.
Hey, what's up?
Uh, mine's not working right for some reason. It's coming up with nothing.
Did you put the space between welcome?
No, it's all. No, there's no space in between welcome.
Okay, well, we'll wait till a few more people finish up and then we'll
All right.
take a look at it and we'll figure. I'll have you show your answer and we'll figure it out. Okay,
All right, no problem.
welcome.
Never mind, I got it.
Okay.
It was something stupid.
It usually is with programming. It's always something little. All right. So can you do screen share, David?
Sure.
All right. So as you see, we start with the inputs for age and input for name. And name input is going to be a string automatically, and we convert age to an integer. And then if the age is greater than or equal to 18, we print welcome and then the name. Else it prints sorry. So there you go. Any questions on that? Okay. All right. So moving on. So what's the result of this code? If 1 + 1 equals 2, then execute this block of code. So if 2 times 2 and 1 + 1 does equal 2, so it's going to execute this one. 2 times 2, if it equals 8, which it doesn't, then so it's not going to print this. And then since this is not true, it's going to execute the else block of code and print else. All right. Oh, so we'll finish up with this section and then we'll stop for the day and have you all work on your resume projects. Kevin, can you read this one?
Else statements. Every if condition block can only have one else statement. In order to make multiple checks, you can chain if and else statements. For example, the following program checks and outputs the num variable's value as text. Indentation determines which if-else statements the code blocks belong to.
All right, so this is just like we covered before, where there we go. Where you've got multiple different blocks of code. So first one, if num equals 1, well, it doesn't. So because num is 3, so we're going to execute the else statement. And if num equals 2, nope, still doesn't, so executes this one. If num equals 3, prints 3, so it's gonna print 3. All right, any questions on that? Okay. Oh, fill in the blanks to compare the variables and output the corresponding text. So x equals 10 and y equals 20. So if x is greater than y, and then we put our colon, because at the end of any if statement, you've got to have your colon. And it does not, so then we print our else statement, else and then colon, print else statement. All right. Brian A., can you read this one?
Let's see. Left statements. Did I say that right?
elif statements.
Elif statements?
Yeah.
Multiple if else statements make the code long and do not very readable. If elf, short for else if statement, is a shortcut to use when chaining if and else statements, making the code shorter. The same example from the previous part can be rewritten using elf statements. As you can see in the example above, a series of if and else statements can have a final else block, which is called if none of the if or else expression is true. The else statement is equivalent to an else or if statement. It used to make the code shorter or readable to avoid indentation increases.
All right, so this one, just like JavaScript, the else if, so it's going to just keep going down the line. So if in comparing them, if this one was true, say this one was 3, then it would have just stopped there, right, and not executed all these. But since it this one isn't true, then it's going to try this one. If this one isn't true, then it's going to try this one. And if this was not true as well, then it was going to execute the final block of code, the else statement. Any questions on that? Okay. So a shorter option for else if is elif. All right, so that is a good place to stop. So stop sharing.